Welcome back! Today we're going to be working on equivalent fractions. Our content objective is students will be able to determine fraction equivalence. Our language objective is students will be able to write and prove the equivalence of numbers. And why am I learning this? Well, it's important for real-world problems like the weight of your cell phone as a fraction. Now, real quick, some background knowledge. In the previous lesson, we did practice turning fractions to decimals as well as percent, and any version of that, we were able to convert them from one to the other. We also practice doing that with repeating decimals. So in a case like this, we express it as a decimal, and we were also able to express it as a percent. Again, some more background knowledge is please remember a rational number is any number that can be expressed as a fraction. So here, notice all of these are rational because you could express them as a fraction. And please remember, a percent basically represents per 100 because cents means 100. Okay, so what is equivalent fraction? Equivalent fractions are basically fractions that are of equal value. Okay, so here are some examples. 2/3 is equivalent to 4/6, which is equivalent to 6/9, which is equivalent to 8/12. How do I know this? Because if I were to reduce all of these down, I will end up with 2/3. Here, if I divide it by 2 and divide by 2, I will end up with 2/3. Here, if I divide by 3 in the numerator and 3 in the denominator, I would end up with 2/3. And here, if I divide by 4 in the numerator and 4 in the denominator, yet again, I would get 2/3. So all of these may look different, but they are the same value. Okay, here, same idea. 28/16 is equivalent to 21/12, which is equivalent to 14/8. And again, if you reduce these, they will end up being 7/4. And here you will see, if I divide by 4, you would get 7/4. Here, if you divide by 3, you get 7/4. Here, divide by 2, you will end up with 7/4. Okay, so now we've also practiced in the past drawing models to show equivalent fractions. So let's remind ourselves how we've done that. Here it says 4/10. So what you do is hopefully have a block that's separated into 10 equal parts. And because it's 4/10, you are going to shade 4 of them. 2, 3, 4. Now what is this equivalent to? Well, instead of separating it into maybe instead of 10, what if you separated them into 5s? You're still going to color in the same amount, so you would fill in 2. But notice, this is no longer 4/10 because there's only 5 equal parts and 2 of them have been shaded. This would be expressed as 2/5 instead. Now, do these represent the same thing? Absolutely. How can I prove it to you? Well, if I reduce this fraction by dividing it by 2 in the numerator and denominator, you would see that I would end up with 2/5. So you can see here, even though that these two look different, they are equivalent and they represent the same value. And you can always tell by reducing it completely to see if they are equal. Okay, so let's try it again. Here, we're going to draw a model to show the equivalent fractions. In this case, it's going to be separated into 18 equal parts, and 12 of them are shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But now instead of separating them into 18, what if we separated them into equal parts of 3? Okay, we're going to go ahead and still fill in the same amount, so up to this point here. So 1, 2. But notice now it's no longer in 18ths. There's a total of 3 pieces, so this is going to be in thirds. How many of the thirds are shaded? 2, so we're going to write 2/3. So yet again, how do I prove it? I can prove it by reducing both as much as I can. If they are equal, they are equivalent. So let me prove it to you by dividing both the numerator and denominator by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So here you can visually see that they represent the same exact thing, even though the values look different. We know that these are equivalent because they represent, yet again, the same value. Okay, what about this one? Here we have 2/3. So here we're going to have 3 equal parts. Okay, turned into 9 equal parts this time. So what should we do? Well, let's start with the same exact shape of the 2/3, but instead of now having 3 equal parts, we must split it to make 9 equal parts. So all I did really was take one part and split it into thirds. So you'll notice here is the original part, but to make it 9, I had to separate it into 3. So here, set of 3 here, another set of 3 here, another set of 3 here is what gave me my 9ths. They're wondering, how many would you have to fill up to have it equivalent to 2/3? Well, here it is up to this point. So if I shaded all of these up to this point, how many are shaded? Let's count. 1, 2, 3, 4, 5, 6. So the answer is 6. But how? Okay, well here, if we want a denominator of 9, in other words, we want it into 9 equal parts, what would you have to do to 3 to give you 9? Well, you'd have to multiply by 3, which means you're going to have to multiply the numerator by 3 as well. So 2 times 3 is what gave us 6. So here we know that 6/9 is equivalent to 2/3. Yet again, we can visually see they represent the same exact value. Okay, so let's try again. We're going to go ahead and turn 4/5 into now something along the lines of 20ths. Okay, so let's first start with an image. 4/5. We have 5 equal parts and 4 of them are shaded. But now instead of having 5 equal parts, I want 20 equal parts. So if there's 5 of them and I want to split them into 20 equal parts, that would require me to take one of them and split them into 4s. So here you have it. I took my original 1 part and split them into 4 equal parts. That way I have 4 here, another 4 here, which gives me 8, another 4 here, which gives me 12, another 4 here, which gives me 16, and my last 4 here, which gives me 20. But now it's wondering, okay, how much will you have to shade for it to be equivalent to 4/5? It is up to this point. So if you shade all that in, you're going to find that you've shaded in 4, 8, 12, 16 of the 20 pieces. So we're going to put 16 over 20. Now algebraically, what could you have done? Well, if you start with a 5 and you end up with a 20, what is happening to 5 to give you 20? Well, it's being multiplied by 4. So if you multiply the numerator by 4, that's how you end up with 16, because 4 times 4 is 16. Okay, because this one part that was originally from the 5 had to be split into 4 pieces. Okay. So now it says determining whether two fractions are equivalent. Like I said earlier, the best way to do that is to simplify it as much as you can to see if they are equal. If they are equal, then you know they are equivalent. If they are not, then they are not. So here, 16 over 20, I'm noticing a factor that can divide both of them is a 4. So I'm going to divide both the numerator and denominator by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So we end up with 4/5. Now looking at this here, 24/30ths, I'm noticing I can divide off a 6. So we're going to divide both the numerator and denominator by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. So that leaves me with 4/5. Guess what? They are equal, which means they are indeed equivalent. So again, if you simplify your fraction completely, and then they are equal, then the fractions are indeed equivalent. Okay, let's try another. We're asked to do the same thing. Check to see if the fractions are equivalent. We have 6/9 and 8/12. I'm going to first reduce as much as I can. Let's see, I'm noticing a 6 and a 9 have a 3 that I can reduce it by, so I'm going to divide by 3, divide by 3. 6 divided by 3 is 2, 9 divided by 3 is 3. Here, let's see, these can be divided by 4. 8 divided by 4 is 2, and then 12 divided by 4 is 3. Guess what? They are equal, which means they are equivalent. Okay, so yes, they're equivalent. How about 12/7 and 60/34? 12/7, there's nothing I can do to reduce it any further, so we're going to keep it as that. 60 over 34. Right off the top of my head, I notice both numbers are even. I know this because it ends in an even number, so 0 is even, and 4 is even, so both of these numbers are even. So I'm going to go ahead and divide by 2. That's going to leave me with 30 over 17. Now let's check. Is 12 sevenths equal to 30 17ths? The answer is no. So are these equivalent? The answer is no, they are not. They are not equivalent. At this point, what I'd like you to do is go ahead and pause the video and try number 7 on your own. Now let's see how well you did. Hopefully you went ahead and tried to reduce as much as you can. I'm noticing between the two I can divide by 8. Okay, so 48 divided by 8 is 6, 40 divided by 8 is 5. I'm going to repeat the process here. I'm noticing I can divide both by a 3. 18 divided by 3 is 6, 15 divided by 3 is 5. Guess what? These two are equal. Therefore, I can say that yes, they are equivalent. So again, the best way to check to see if fractions are equivalent is to reduce them down as much as you can to see if they are equal. Okay, now it says, convert the improper fraction to a mixed number. Draw a model to show the equivalence. So it's always important to first identify with the denominator. Here, since we have 7/5, we know to separate each block into 5 equal parts. So here we have 5 equal parts. We need to shade in 7 of them. So we have 1, 2, 3, 4, 5. Guess what? We need more. So I'm going to go ahead and introduce another set of 5 equal parts in a block. I already shaded in 5, so I'm going to go ahead and shade 2 more. So now, here, this represents 7/5. So both of these were in fifths, and I went ahead and shaded 7 of them. So what is this equivalent to? From what I see here, I have 1 whole, okay? And then here, I notice I see 2 out of the 5. So I'm going to go ahead and say that 7/5 is equivalent to 1 and 2/5. 1 whole here, and then 2 out of the 5 equal parts here. Okay, let's try number 9. Same idea. Here we have 13/4, which means we're going to go ahead and separate each block into 4 equal parts. So here we have 4. We're going to go ahead and shade 13 of them. So here, the most you'll notice is I can shade in is 4. So I'm going to have to introduce another block with 4 equal parts. So we have 4, 5, 6, 7, 8. Still not enough. I'm going to introduce another block of 4 equal parts. So we had 8, 9, 10, 11, 12. Yet again, still not enough. Introducing another block of 4 equal parts. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, what is this equivalent to? Hopefully you can see that these are 3 equal parts. So there's 3 of them, not 3 parts, I apologize. 3 wholes. So 1, 2, 3. And then we just have 1 out of the 4. So how would you write that? Well, there's 3 wholes, so we're going to say 3 and 1/4. These two are equivalent now, because you can visually see once again the same amount is shaded in the same shape. Okay, now it says plot each of the following on the number line below. Okay, this is background knowledge. You've done this in the past where you've plotted all the points on a number line. Here is 1/2. It's in the middle between 0 and 1. -3/4 is right here. It's 3/4 of the way to your left. 2/5 is if you separated these into fifths. 2/5 would belong here. And the -1/3 would belong here. So this is stuff that you've done in the past. But now let's look into that a little bit more. What this does, it allows us to visually see what number is greater than what. So for example, you'll see here, first let's understand the further you go to the right, the larger the number gets. The further you move to the left, the smaller the number gets. So here, since 1/2 is further to the right than 2/5, I know 1/2 is larger than 2/5. Here, since 1/2 again is further than -1/3, I know 1/2 is greater than -1/3. And here, since 1/3 is further to the right than -3/4, I know that -1/3 is greater than -3/4. And so on. Now, using equivalent fractions to compare fractions, this is what we're going to do now. We're going to try to figure out which is greater. And what if we don't want to plot it on a line? What could we do? Well, first of all, it's definitely beneficial to compare them when they have the same denominator. So what I'm going to do is look for the lowest common denominator, which is 60. Now, if you're wondering, how did I get to 60? Remember what I do first. I ask, can the smaller number be multiplied to give you can the smaller number be multiplied to give you the larger number? The answer is no. 15 cannot be multiplied by a number to give you 20. So in that case, I'm going to choose a larger number and think of multiples of the larger number. First is 20, didn't work. 40 is next. Can 15 be made into 40? No. The next multiple is 60. Can 15 be multiplied to give me 60? Yes, so that is my lowest common multiple. Now we're going to adjust it. What happens to 15 to give me a denominator of 60? Well, you would have to multiply it by 4, which means if I multiply the denominator by 4, I'm going to multiply the numerator by 4 as well. So 4 times 7 is 28. So now we're going to refer to 7/15 as 28/60. Both of these are equivalent to one another. Okay, now let's see here. How did a 20 become a 60? Well, we would have to multiply by 3, so let's do that to the numerator as well as the denominator. So now the new numerator is no longer a 9, it's going to be 9 times 3, which is 27. And notice here, 20 times 3 is still 60. By having it both in 60ths, I can quickly see which one's greater. From this, I obviously can see that 28/60 is greater than 27/60, which means the original means 7/15 is greater than 9/20. Okay, so let's try another one. Here, first, it's a good idea to describe both of them with the same denominator. So here, the lowest common denominator between 5 and 7 is going to be 35. 5 is going to have to be multiplied by 7, so we're going to multiply both by the denominator and numerator by 7, leaving with the new numerator of 28. So notice 4/5 is equivalent to 28/35. I know this because if I reduce this by dividing numerator and denominator by 7, it brings me back here. Here, what is being multiplied by 7 to give you 35? It is a 5. So here, our new numerator is going to be 5 times 5, which is 25. So I can quickly see that 4/5 is greater than 5/7 because 28/35 is greater than 25/35. Okay, now at this point, what I'd like you to do is pause the video and try number 12 by yourself. Okay, so let's see how well we did. First, it's going to be a good idea to have both fractions expressed with the same denominator. So I'm going to ask myself, what's the lowest common multiple between 12 and 9? Hopefully your answer is 36. 12 can be multiplied by 3 to give me 36, so the numerator is going to be multiplied by 3 as well, giving me 15. 9 can be multiplied by 4, so we're going to multiply both the numerator and denominator by 4, leaving me with 16. So in this case, you're going to find that 4/9 is greater than 5/12 this time, because 16 is greater than 15. Okay, so now go ahead and pause the video to try 13 on your own. Okay, so let's see how well we did. So here, we're going to find the lowest common multiple between 8 and 9, which is 72. You're going to have to multiply the numerator by a, oops, I went ahead of myself. You're going to have to multiply by 9, and that's going to give you a negative 27. Here, you're going to have to multiply by 8, which is going to leave you with a negative 32. Now, some of you may be too quick to answer this question. You may think it goes this way, but you would be wrong. Why? Please remember, the further you move away from 0, the smaller the number gets, which means the higher the numerator, the further you're moving away from 0. So the correct way to write this would actually be that negative 3/8 is greater than negative 4/9. This is the trickiest part because of the negative, so please pay very close attention to that detail. Now let's take a look at number 14. Here we have negative 2/7 and negative 3/10. There's two ways to do this. If you wanted to, you can simply divide a 2 by a 7, and you would end up with a negative 0.2857, and so on. And it is negative. And here you can quickly compare that to a negative 3/10. Again, the further you get away from negative to the left, the smaller the number gets. So we're going to say negative 2/7 is greater than negative 3/10. Now another option, which is going to take a little bit longer, but I just wanted to show you, would be to compare them like this, negative 2/7 to negative 3/10. You can go ahead and once again find the lowest common multiple. Here it would have been 70, so you would end up with negative 20/70ths, and then here you would have negative 21/70ths, and then you can see, oh yes, this is greater. Okay, so please don't be fooled with the numerator and what's bigger, especially when there's negatives involved. You have to think carefully. Now the instructions say to order the fractions below from least to greatest, then plot on the number line. So the very first thing I want to do in order to order them from least to greatest is I want all of them to have the same denominator so I can quickly assess what's the smallest, what's the greatest. So here, the lowest common multiple between 5, 3, and 9 is going to be a 45. So here, I'm going to express 7/5. If you'll notice, I multiplied by 9 to get me 63 over 45. Here, I'm going to multiply both the numerator and denominator by 9, leaving me with 27/45. Here, in order to get 3 to become a 45, I'd have to multiply by 15, leaving me with negative 15/45. And last but not least, I'm going to have to multiply by 5 to the numerator and denominator, which would leave me with 5/45. So obviously, this is what represents this number, this is what represents this number, and so on. But in order to order them from least to greatest, I'm going to rely on this. So here is the smallest number, so I'm going to first write a negative 1/3. The next smallest number would be this one, so I would say then 1/9. The next smallest number is going to be this one here, so I'm going to write 3/5. And last but not least would be our 7/5. Okay, so let me clean that up a bit. But now we're asked to plot them. So here, negative 1/3 would be a third of this. Here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a third of it's about 33, it's going to be about a third of it. So that's going to be about 33.3%. So here we go. Here, 1/9. If you ever question it, the best way I think would be to divide it so you can get an idea of where it falls. So if you did 1 divided by 9, let's see, that's going to go in about ones, with the remainder of 1, and you're going to notice it's going to repeat itself. So this is basically 0.1, and it is positive, so it's going to be somewhere here. Okay, 3/5. If you remember from the previous lesson, if you can get things to be in terms of hundredths or tenths, it makes things a lot simpler. So here, if I have 3/5, if I can convert it to a tenth, for example, I'm going to go ahead and multiply the numerator and denominator by 2, which leaves me with 6/10. And what's nice is this is already in tenths. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 1 whole. So here is what made it easy for me. Next, 7/5. Okay, well first of all, fifths, okay, we're going to go ahead and turn them into tenths. And the way we do that is the same by multiplying both the denominator and numerator by 2. So here I would have to go further, and actually I think I would run out of room, because here's 10/10, 11/10, 12/10, 13/10, 14/10. So it actually falls off the number line, but let's pretend we still see it. But it does technically fall off. Okay, so please keep that in mind. We kind of ran out of space there. And guess what? That is going to conclude the lesson for today. Hopefully you learned how to figure out equivalent fractions, to see if they are equivalent, how to create equivalent fractions, and what they would look like. Thank you so much for tuning in, and as always, until next time, bye!